Welcome to Math 109, brought to you by Coronavirus. And here's a look at the PDF that contains all of your Lesson 4. So let me get out of that mode and pull this up here. Okay, let's take a look at your P&L that you've been working on, I hope. Introduced you to pie charts and everything. Actually, we went over this in class on, or at least part of this in class on Wednesday. For those of you who were here, you'll remember this. This is what you should have finished before the class. Please excuse the poor audio quality. It should improve when I get the correct adapter for my microphone later this week. Okay, looking at this, the average household income is given to us here on this graph. Select the best phrase to complete this sentence. The numbers on the horizontal axis, the line across the bottom of the graph. Okay, so we're talking this. Okay. Represent the income from 2001 to $2013. No. They represent the years along the horizontal graph. The best phrase to complete this sentence? Let's see. The numbers on the vertical axis. Well, here's the vertical axis. Represent years? No. Income for a household or family? Average household income, okay. From 50,000 to 56,000. Let's see, there's 50,000. Okay, and there's 56,000. So it looks like that is the correct one. Okay, what else do we have, though? Might be a possibility. Okay, so let's circle that one. Let's see. The income for one person from $50,000 to $56,000. No, it said it was income for families. Income in 2012. No, that would just be this amount. So 2II there is the only one possible. And all right, let's move on to the next page. See what we have there. I think I need to switch tools. There we go. Okay, now I will not always go over everything on the P&Ls, but this video is showing you the capabilities of the tool as much as anything. Okay, let's take a look at number 2 here. And right here. In 1990, looking at pair 1, pairs of facts. In 1990, Jeff spent $600 per month on housing. But in 2010, Jeff spent $1,200 per month on housing. So look at that. His income, or how much he spent on housing per month, went up 2 times. Okay. So looking now at pair 2, in 1990, Jeff spent 20% of his income on housing, but in 2010, Jeff spent 10% of his income on housing. So that's 1/2 of his original cost. So what's going on? How is that possible? How can they both be true? If Jeff spent 20% of his income on housing, but then 10 years later he was only spending 10% of his income on housing, what could have happened? So these are the questions you ask yourself when you go through this. Well, even if his income or his expenditures on housing had remained the same, if his income went up, that would make what he spent on housing a smaller percentage. And if it went up substantially, then wow, yeah, he could have spent twice as much on housing, but if his income went up even more, it still might have only been 10% of his original income. Okay, so let's see if we can figure this out. In 1990, Jeff spent $600. Sorry, that doesn't look like 600. $600 per month on housing. And that $600 was equal to 20% of his income. Okay, so we don't know what his income was at that point. But we can figure it out, can't we? Okay, if we now cross multiply, we'll get 20 here times x, or 20x, equals 600 times 100, or 60000, and put in my comma, 60,000, divided by 20. So his income at that time was only $3,000. Okay? But then if we look at what happened in 2010, Jeff spent $1,200 per month on housing. Okay? And in 2010, Jeff spent 10% of his income on housing. So that would be $1,200 over, we don't know his income yet. Okay, and that's equal to 10% of his income. So once again, if we cross multiply, 10x equals 1200, and add 2 more zeros to it. And divide by 10. Okay, so that's going to actually just drop off 1 0 there. 12000. $12,000 was his income in 2010, whereas in 1990 he was only making $3,000. Now, notice we're talking about per month. So as long as we are thinking about this per month, and this is his income per month, okay, if that were income per year, he'd be cutting it close. Let's see if this is per month to get to how much he would make in a year. We just multiply by 12, right? Let's do that and figure out what that is. $36,000. Okay. That's okay. You can get by on that. Now let's see what he was making 20 years later. Okay. So 12,000 times 12 months Whoa, did I do that right? 144,000. Yep. That's a good salary. So Jeff could definitely afford that extra expense per month for housing. So that's the type of analysis we should be doing as we work through this lesson. Okay, this next part I really wanted to go over with you because it's kind of tricky. Not tricky, but just you don't usually think of things this way. At least I don't when I'm reading a graph, because take a look at these two graphs of the U.S. Hispanic population. One is in 2010, the other is the projected U.S. Hispanic population in 2050. However, there are no absolute numbers here. It's just a proportion. What percentage of the U.S. population is Hispanic or is expected to be Hispanic? So in 2010, Hispanics made up 16% of the population and non-Hispanics 84%. So the projection is that in 2050, Hispanics will make up 30% of the population and non-Hispanics will make up 70% of the population. Now, the comment over here is that this pair of graphs cannot be used to predict that the number of non-Hispanics in the United States is expected to decline between 2010 and 2050. In 1 to 2 sentences, explain why. Okay, if Hispanics are going to be a larger percentage of the population in 2050, why wouldn't you assume that Well, Hispanics are going to be a larger percentage of the population. Non-Hispanics are going to be a smaller percentage of the population. Why doesn't that mean there will be fewer non-Hispanics in 40 years? How could that happen? Well, if the population of Hispanics increases at a faster rate than the population of the non-Hispanics, then both populations would increase. But as a percentage of the whole, the Hispanic population would be a larger percentage of the whole because their population increased faster than the non-Hispanic population. So be careful how you look at these things. Don't assume a graph is saying something when it may not really be saying that. Okay, and we already started this lesson, but make sure you look at all of the specific objectives as we prepare to meet Monday afternoon at 1 o'clock on Blackboard Collaborate. Okay, so make sure you take a look at all of those. That's what we're going to be working with. Let's see, where's my next page? Over here. And hopefully Blackboard Collaborate will let me manipulate this as much as we've manipulated everything else. All right, so we looked at these two graphs. We compared them in class. I hope you remember doing that. Okay, and then we will be looking at reading bar graphs. So I look forward to seeing you tomorrow. I'm a little bit clunky with this new app, but hopefully we will improve, both you and I, with this online stuff as the semester goes on. Take care, wash your hands, stay healthy. I'll see you tomorrow on Blackboard Collaborate.